Welcome to another lecture of our DBMS playlist. Today we are going to learn some properties of functional dependency. So first we need to understand what a functional dependency truly means. So this is how we truly write a functional dependency. X determines Y. That is how it is read. Here this X attribute is called determinant and the Y attribute which is dependent on X is named as dependent. Okay, so suppose let's have an example. In a table there are two columns, SID and SName. So suppose in the SName column we have two similar names, that is AB and AB. So how we can distinguish if that there are two students of similar name or it is the name of the same person twice? So that SID will come and help us in that matter. So we will check here. So for these first two rows the SID's value is same. Okay, so from that we can understand that this is the same person with SID1 and name AB and its name is written twice. And now let's come to these two particular rows and see, this is also having same name AB, but here the SID is different. So this determines that these two are different persons with same name. So here SID is determining whether the SName attribute is having same value or different values. So that means SID is determining SName. So that's how we write a functional dependency. So now let's check its properties. First is the reflexive or trivial property. How we understand it? So let's see. If there is a functional dependency, that is AB determining E, then this also means that AB can determine A, B and AB, all of this. Okay, so if it was a single attribute on the left side, suppose A to C, then we will having A can determine A. But as we have two attributes combined on the left hand side, this means it can determine both of the attributes and the combined part. Okay, so AB can determine A, AB can determine B and AB can also determine AB. Okay, so that is the functional dependencies we are getting from this reflexive property. So now let's get to our next property, it is augmentation. So what is it? Let's check. If there is a functional dependency, that is A determining B, then we can write AC determining BC. We are doing what? We are just adding C on both sides. Okay, so we can add any other attribute on both the sides, and then it will still be a satisfied functional dependency. Okay, so again let's read it. If A can determine B, then AC can determine BC. Okay, so now let's go to our most important property. It is the transitive property, which I have already explained in my previous video once. We will see it again. So if there is a functional dependency, that is X can determine Y, also if Y can determine Z, then we can say that X can determine Z from the transitive property. I think we already know what is transitive property. So if X can determine Y and Y can determine Z, then X can determine Z. This is the transitive property. So this is important. Okay, remember that. Also let's move towards our next property, it is union. So let's check. If A can determine B and A can determine C, then we can say that A can determine both B and C together. Okay, so if A can determine B and C, then A can determine BC also. That is the union property. And what is the decomposition property? So for that particular decomposition property, remember that it is done only on the right hand side. Okay, decomposition is done only on the right hand side. Suppose if there is a functional dependency that A can determine BC, so we can write that A can determine B and A can determine C. Okay, so this is just the opposite of the union. Okay, so there we were having two different functional dependencies, we combine them into single one. Here we are doing the just opposite thing. We have a functional dependency where A can determine BC and we are just dividing the right hand side. Okay, so A can determine both B and C differently. Okay, so now let's check what is composition. So suppose there is a functional dependency A can determine B and there is another functional dependency that C can determine D. Okay, so now we will just add them together, that is AC, that is on all the left hand side attributes will be on the left hand side AC, and all the right hand side attributes will be on the right hand side. So AC can determine PD also. Okay, so see, we were having two different functional dependencies, and we are just combining the left hand sides of both the functional dependencies and the right hand sides of both the functional dependencies. Okay, so that's how we are getting AC can determine BD. So now our last property, that is pseudo transitivity. So what is it? Suppose A can determine B and BC can determine D. So see here, if we have B can determine D, then it will be transitivity. Then we would have written that A can determine D. But we have what? We have BC can determine D, and B can be determined by A. We have already know this from our first functional dependency, that B can be determined by A. So we can replace B with A. So now it will become AC can determine D. So that is our pseudo transitivity works. Okay. So hope you understand these particular properties of functional dependencies. Please subscribe and share this playlist with all your friends. This will going to be very helpful for you. So goodbye for today.